Hello, I'm Christo, and in this second video about CppModel framework, I will show you how to put validation on your simulation logic. If you remember from the previous video, our outputs from the model were in the range 300 to 700 milliamps, and they also are zero if the joystick input command is zero. So let's add some verification of that logic. Okay, we have verification for both of our outputs. Let's define a public variable that will allow us to report error if this verification is not met. I will just define it here. Okay, and let's add that to the functional result, to the program result, sorry. So now our executable is ready. I would like to prepare a bat file which will help me with compilation. And I will just copy the commands for compilation in here, so I don't need to rewrite them every time I want to compile. Let's compile. And let's run our simulation. We expect it to end with result 0, which is indicated by a blue dot in front of the execution row. Let's go on and fail the simulation now. Let's say that we'll have a joystick that changes its signal between 0 and 5000, for the whole time of the simulation. So instead of going to starting from 500 and going to 4,500, we will just go to 5,000 without a minimum. Let's recompile. And let's run it again. And now we see in front of the row a red circle with the cross, which indicates that our simulation had failed. And that is because we return -1 here. Before we go to the CppModel workspace, I would like to add one more thing here, and that is a system variable that allows CppModel to indicate when exactly the simulation had failed. That variable is added to outputs, and it's called CppModel step result. And when the outputs are in range, that variable will be set to 1. And if they are not in range, it will be set to 0. Let's recompile. And rerun the simulation. And let's go and observe the result of the simulation. Okay, so there is something new on this screen, and that is the graph below the process graph. And that is because we added the system variable CppModel step result. That graph gives us information on each and every step, what is the result of the validation process. And you can see that in the beginning, as the values of the output down go above its maximum, the graph underneath indicates that the validation had failed. And the same happens on the other side when the output goes above its maximum. Let's not leave it like that. Let's go into our logic and fix this. I will go directly to the boom control logic, and in the function output scaling, I will add some boundary trim. Let's see if this fixes our problem. We compile all the files again. And the initial result is positive. We have a blue dot, which means that the simulation is successful. And let's go to our workspace and refresh and see what are the results. And yes, here you can also observe that even though the joystick is below its minimum, the output value stays to its maximum value, and the same is on the other side. Okay, this concludes this video of how you can use CppModel to verify your logic. Please let me know what you think and watch also the other video of how you can use CppModel to simulate your program. Thank you for watching.